So in this exam, we have two files, Physicians 2020, Physicians 2024. We've got the unique ID for each physician, last name, first name, zip code, primary specialty, gender, graduation year from medical school, and the name of the medical school. Create a union. What is the unit of observation? Let's do that. So I'm already connected to Physicians 2024. I'm going to convert it into a union and drag in Physicians 2020. So I have a union of those two tables. I see I have NPI, that's a number. We'll probably convert that into a dimension, last name, first name, gender, table name, fantastic. What is the unit of observation? Well, let's make NPI a dimension because it's an ID. We're not going to do any numerical operations on that. Let's add that in. Let's put in our count variable, and we see, not surprisingly, that we have twos and ones. Some physicians are in the combined data set just once. Some physicians are there twice. That means they existed in the Medicare file both in 2020 and in 2024. So let's do a table name. Seems like a good way of differentiating those two observations. And indeed, we see this physician with this ID is in the data both times, and the NPI and table name uniquely identify each row of the combined data set. So the unit of observation is a physician and year. Physician as identified by NPI, and year as identified by table name. Next, using count_d function, create the number of physicians, horizontal bar chart, and so on. Okay, so let's create a new field. I'm gonna call it the number of physicians, and it's going to be count distinct of NPI. Fantastic. Let's see how many physicians we've got. Total 144,000. So we have 250,000 observations or so. And so majority of physicians are there in both years. So 144,000 is in the right ballpark. We're supposed to do a bar chart where we have the medical school, different medical schools, and figure out which medical schools have the most graduates. Wayne State University, Indiana, University of Minnesota Medical School. All right. And we're supposed to explain why do we need to use the calculated field, the count_d function, rather than simply the number of observations. Well, let's actually contrast that. So here I have the number of observations. I have that for Wayne State University. I have 4,500 observations, but only 2,600 physicians. Of course, the number of observations just duplicates physicians because some physicians are in the data twice. And so we need to use the count_d calculated field to see how many physicians in these 2 years graduated from, or how many physicians among the 2 years that are in the data set graduated from Wayne State University. Okay, fantastic. In the next question, we're supposed to simplify that medical school name. We can clearly see here that these are pretty long school names. If you want to use these names as labels on a map or something, maybe we want to use shorter names. So let's create a calculated field, and let's call that med school shorter. And essentially, all we have to do is always replace these three phrases with nothing. So I'm actually going to take a Control C on that and go back here and say, well, replace. Oh, not replace, not regex. Replace. And I'm going to do this 3 times, actually. So I'm going to replace and then replace again. Oh, replace again. And then replace again. And so I'm going to replace, which string am I going to be replacing? Medical school. And the first term is just to I'll just actually type it in. It's School of Medicine, then College of Medicine, and Medical School. Okay, I'll try to remember that. So in all caps, School of Medicine. All right, and that's going to be replaced with nothing. And then that we're going to look for what is it? Medical. I already forgot. College of Medicine and then medical school. So I'll do medical school, and that's going to be replaced with nothing. And then inside that string, once that is replaced, I'm going to look for College of Medicine. College of Medicine, and that also will be replaced with nothing, just quote and quote. And I must have an extra parentheses here. Okay, so this is a long expression. I basically nested a bunch of replace. I first replace medical school. Oh, I have Tableau search for School of Medicine. In med school field, it replaces it with nothing. That is then the input into the second replace function. It looks into that field, looks for medical school, and replaces it with nothing. And that is then fed to my third replace function, and it looks for College of Medicine and it replaces it with nothing. So I'm going to say okay to that. Let's actually see how this works. I think I was supposed to duplicate the field, so sure, don't duplicate the sheet. So medical school shorter. Let's see how that looks. And here, yes, I have Wayne State University, Indiana University, University of Minnesota. So that's a little shorter, a little nicer list of schools. All right, so that's my rename. That's question 3. Perfect. Let's go to the next question. There's no story. We're not doing stories. Okay. Question 4 asks, create a field map showing zip codes that have at least one physician. How many zip codes does your map show? And then can you fix it? So we do have a zip code field here. Now, in the exam, we're warned that some zip codes are 9 digits, some zip codes are 5 digits. Let's see how that works. Let's double click on this. Make it a filled map. And we have a 62,000 unknown. And we can actually click on this, edit locations. What are the unknowns? So this zip code is unrecognized. These are all 9-digit zip codes. So it looks like Tableau really does not understand 9-digit zip codes. So one thing we can do is turn the zip code into a character and then into a string variable, and then just use the left function to grab the 5 leftmost characters. And so we can do that by going into our data source. And in the data source, let's take the zip code and change. See, right now, assigned it a geographic role, but it's really a number, a whole number, which is a little bit of a problem because the leading zeros, the zip codes that begin with 0, are not going to work properly, because if it's interpreted as a whole number, that 0 at the beginning is ignored. So I'm going to turn it into a string, because it's going to lose that geographic role. I can always assign it the geographic role later. Oh, actually, it still kept it that way. All right, well, that's okay. It's fine. So we'll leave it. We'll keep it as a string, and we're going to create a new calculated field. Create calculated field. And it's going to be zip corrected. And it's going to be left of zip code first 5. I will say okay to that. And I'm going to assign it a geographic role as a zip code. And maybe even before I do that, I'm going to check it. Here's zip code corrected. Here's the old zip code. And that actually looks pretty good. Pretty good. All right, so I only take the first 5 digits. I have the leading zeros. Yeah, I can actually delete this. I'm not going to need it. I'm gonna go here and replace the zip code with the zip code corrected. And now I have lots of zip codes. Now I have only 34 unknown zip codes. I don't know why Tableau does not recognize these zip codes. Maybe they're from old zip codes or really new zip codes. Somehow they don't match zip codes that Tableau has in its database. Okay, let's do next question. Okay, I'll say okay to that. Next question is 5. Create a field map where each state has the color of the top medical school in that state. Yes, so we've done this a number of times. We want to have, and let's use the shorter one. We want to have a medical schools, and we want to have a state, and we want to have the number of physicians in the table, and we want to do a table calculation where we're going to calculate the rank of each school in descending order. Let's make it unique in case we have ties. Table across. So within a state, across medical schools, we want to know which medical school is number 1 in that state. Okay. So in Alabama, we have to look really, really far. So let's actually put in the filter right away, and let's look at just the rank. That's number 1. And in Alabama, it's the University of Alabama. It's the number 1 medical school of the doctors that practice in Alabama. Let's select let's select all of these combinations of state and medical schools. Let's create a set. Let's say top med schools. We've got 49. Yes, that's because we just have the 48 states plus DC. So that makes sense. I'll say okay to that. That's my helper sheet. Now I'm gonna create a filled map by state, where I'm gonna map medical school to color. Okay, and I'm gonna use only the observations that are in that set. Let's actually put these medical schools on a label. Here we got University of Washington is the top school in Washington, and apparently also in Montana and Oregon, North Dakota. Yes, so this all makes sense. University of Vermont. Actually, University of Vermont is the top medical school of the doctors that practice in Vermont. Okay, so this is all very nice. Let's do number 6. We're supposed to create a dashboard that combines these two, that combines the bar chart and the filled map. So let me actually call this guy as is that question 6? I think so. That's question 6. So I'm gonna leave it, and question 3 is my bar chart. So I'm gonna create a dashboard. Question 3, question 6. Let's put that at the top. Oh, do we want this legend? Maybe not. Let's actually, so then we have a little more space, and we have a pretty nice dashboard. Okay, but we're supposed to create an action. So dashboard actions. It's supposed to be a filter action. Okay, where the source is the map and the target is the bar chart, and it's going to run on hover. And when we stop hovering, I'm gonna just show all values. So we might have to come back to this, because I think if I just hit OK here, I'm gonna have a problem. I see that in Arizona, okay, University of Arizona is the top. I only see one school here. And why is that? Well, that's because in our action, where are they? Dashboard, actions. Let's edit that action. When the filter happens, it's filtering on all fields. And as we're hovering over the state, we're also hovering over a mark that is the color, and it's the color of the medical school. Okay, so it's filtering not just on state, it's also filtering on medical school. So we only need to filter on state. So we're going to change this to selected fields, and we're going to select on state. I'll say okay to that, okay to that. Now let's see what happens now. All right, in Wyoming, Creighton University, and then University of Utah, University of Colorado. Those are schools number 2 and 3. In Maine, we've got University of Vermont, Massachusetts, Tufts, Dartmouth. Okay, that makes sense. Okay, so this is our question 6. I'm going to rename that. That's Q6. All right, let's move on to, oh, I already did that. Okay, so maybe it's a question 7 then. I'll have to check that. No, so I'm going to have to renumber these guys. Sure, just bear with me. So this is question 5, and then this is question 6. All right, and let's go to question 7. Now, question 7 says, well, let's just look at the UCLA and Albany Med. So let's go to, let's put in a filter for those two medical schools. So I'm going to select Albany Med and UCLA there. Okay. And we'll do, what am I supposed to do? We're supposed to create a map contrasting the locations of Albany and UCLA physicians across US states. So states, it's going to be our geographic level of detail. So I'm going to do state. And I'm going to see, well, how many physicians from these two schools operate in each state. And I'm of course going to differentiate between those two. Of course, here I have only two of them. I have Albany Med and UCLA, and I really don't like those, that yellow and blue. I'm gonna change it to red and blue. Let me make this even bigger. All right, and what do I have? I certainly have a problem of overplotting. I bet that there are some UCLA doctors or doctors that graduated from UCLA that are working in New York State, right? This is New York State. So let's control for that overplotting by going to colors and maybe having a 50-50 opacity. And you can see, yes, indeed, in New York, there are a bunch of doctors that graduated from UCLA. And of course, there are some doctors that graduated from Albany Med working in California. We could also probably make it a little more transparent by adding a little bit of a border to see that there are two circles in each state. But it's clear that doctors or medical students tend to stay where they went to medical school. I mean, certainly, most of the Albany Med students are in the East. A lot of the UCLA students are staying in California or in the West in general. We could see that the blue circles are usually smaller than the red circles in the West and vice versa in the East. And it's neat. So they're almost identical in Texas, just kind of in Texas and Colorado, which are halfway through, or even here. Okay, so that's question 7. Oh, no, yes, question 7. Let's go to next one. Question 8. Among the top 10 primary specialties by the number of physicians, which specialty has the highest proportion of women? So top 10 specialties. All right, so let's put the specialties at the top here. Let's filter top 10 by, not by city, by number of physicians. Okay. And we're going to count the physicians. And we're going to differentiate them by gender. Okay, again, let's make women red, men blue. Okay. And but I'm supposed to show stacked bar chart, so that's what this is. You can see family practice. Should I make it family practice? Is really the most common specialty. I could probably even sort it that way. Ophthalmology is the number 10. Internal medicine number 2. But I'm supposed to have these bars add up to 100%. So I'm going to use a table calculation on the number of physicians, and it's going to be percent of the total, and it's going to be, well, it's not going to be table down. Oh, yeah, I guess it can be table down. It's going to be table down. So by each, yes, by each value of specialty. Okay, perfect. And I can put that number of physician also on a label, and adding the same table calculation, percent of total, down. Okay, so this is a pretty nice table. This is a pretty nice table. I can see that obstetrics, okay, I did something wrong. I need the table calculation, not table across, table down. I see that 56% of physicians in the obstetrics and gynecology field are women. Orthopedics. Orthopedists seems really dominated by men. Okay, so this is really nice, but in question 9, I want pretty much the same figure, but now I don't want to show the men, because I know that the men are just the remainder of women. I just want to see, all right, obstetrics 56, the next one in line 36, and so on. Yeah, so let me duplicate this sheet. If I use gender, and I show filter, and I just say, well, give me women, it breaks. Because if I don't have women in the table, then really women make up 100% of the physicians in the table. Right? And so this is the problem that we have with the table calculations, that the table calculations really depend on the structure of the table. One way we can fix this is by using LOD expressions. So let's create an LOD expression for number of physicians by specialty. Essentially, I want to calculate the denominator, because if I'm going to be calculating the share of women in a particular specialty, I want the denominator to be the total number of physicians. So number of physicians by specialty. Okay, and so I'm gonna fix, this is gonna be fixed by primary specialty. And I'm just gonna do, well, I'm gonna do count D of NPI. Yes. And close the parentheses. I'll say okay to that. And next, I'm gonna create a calculated field where I will have a share. It's just gonna be count D NPI divided by I'll do just the sum of number of physicians by specialty. Okay. I'll say okay to that. And so I know that I'm looking for obstetrics have a 56% of women. So let me get rid of this label. Let me get rid of the table calculation, and let me put my share variable up here. But now I actually don't need to see men, and I can sort it this way. And I can certainly format the share to be a percentage on the axis. Sure, just 0 decimal places is okay. I can also put that share onto a label, and again format it as a percent. And perfect. And I see 56% of obstetricians are women, 37 family practitioners are women, and so on. And here are the orthopedists, only 5% are women. Perfect. So using an LOD expression, we're able to create, I think, a cleaner table. That gives us a little more white space here. I think it's perhaps a little more informative than the previous table. But most importantly, we learn that we can do this using LOD expressions. Next question is, and create a calculated field that flags each physician as retired, continuing, or entered. And create a table showing the number of physicians in each category and the median year of their graduation from medical school. Okay, so this is going to be another application of LOD expression. And so we have just 2 years. So it's going to be pretty simple. And we could certainly do it the more complicated way by creating the 0, 1 variables for each year. But we can, let's see, what's the best way of doing this? I'm still blank. What's the best way of doing this? So let's create a year field. Okay, let's create a year field. And I'm gonna do that here. I can't do it now. Yeah. It's going to be recorded.
I'm making a cake from scratch.
Wow, thank you.
Doesn't that taste good?
Yum. Very calculated field. Let's call that year. And it's going to be from the table name. We're going to get it from the table name. We'll take right of split of table name, where we're going to split on the dot and take the first one. So it's going to give us physicians without the .csv. So it's going to give us physicians 2020 or physicians 2024 without the .csv. And then we're going to take 4 rightmost characters, and that's going to be either 2020 or 2024. Let's make that a number by integer. Now let's see if that actually works. I'll say okay to that. Sure, let's do table name and let's do year. Of course, that's adding it. So if I do average, yeah, I'm doing the right thing. So that's going to help us a little bit. Now, let's create a new field, and I'm going to call it status. And we'll do if, and we're going to fix at NPI and ask if the maximum of year equals 2024 and all right, okay, so hold on. If the maximum of year, I'll need to close the LOD and I'm going to do fixed again. NPI colon min of a year equals 2020, then this physician is continuing. Else if, let's actually do this. Let's copy that. Control C. P. So if the maximum year is 2020 and the minimum year is 2020, then this is retired and okay, and else well, it should be just new. Okay. New. Okay, what did I say? No, I said entered. Entered. And all right, and forgot then here. Let's see. I'm gonna say okay to that. I actually have to pause this for a moment. All right, so we created our status variable. Let's actually just check it. Let's go back here to where we were first trying to find the unit of observation. And let's put the status over here. And let's see if it's giving us the results that we are expecting. So this physician here is continuing. This guy has retired, continuing. Let's find somebody who entered. Just saw it here, this guy. Yes, because that NPI is only in the 2024 file. So our status variable works. Let's see how many positions we have in each category. So here's status. Here's the number of physicians. We see that 107,000 are continuing, 7,000 entered, 30,000 retired. So really the number of physicians has declined by how much? By about 23,000. And is that consistent with what we have in terms of the number of observations in each file? Yes, indeed. When we see that in Physicians 2020, we have 137 and then 114, that's at about 23,000 difference. Let's check the median of the year in which these folks graduated from medical school. It's not what I wanted. I want just put it in here. Wonder why my graduation year shows up as among dimensions. So let's convert it into a measure. Let's put it in here. Let's make that a median. And we see that those who retired had a median year of graduating from medical school, 108, 1985. Those who entered graduated more recently, 1995. Not that big of a difference from those who continued. Their median is 1994. Okay, fantastic. Our last question, question 11. asks, well, let's calculate the physician churn as the percentage of physicians who either entered or retired. Um, and create a bar chart showing this physician churn by primary specialty. So here we basically want to calculate churn. We basically want to calculate a share. So I'm going to, let's see, I'm actually going to duplicate this sheet because I want to make sure that I'm doing things correctly. And I can see what the churn is in aggregate, not by specialty. I can see that if I don't break it down by specialty, the churn should be basically 7,000 plus 30,000 divided by 144,000. Because if I go here and I add a total, yeah, I have 144,000. Well, we have this variable share. It just counts the physicians. And then the sum of physicians by specialty. Now, if I don't break it down by specialty, it's just going to give me the total number of physicians. So let's see what happens if I drag this guy over here and format it as a percentage. Format, percentage. And I see that I have I have uh, I have I have entered and retired separately. But to calculate churn, I need to combine them. So I'm going to take my status and we called it create groups and entered and retired. We're going to group as churn. And then continuing is on its own. And so I'm going to replace that this and delete the status. And I see that I have 37,000 physicians who either entered or retired. I have 107 continuing and 144,000 total. So the share, the churn is 26% in aggregate. So I can take my group. I can say, well, I only want to see the churn. Can get rid of the total. And I can make this. Actually, I'm just going to show not this guy and not this guy. I'm just going to show the top 10 medical specialties. Top by field, by not by share, but by number of physicians. Okay, I'm going to make the share a on rows because I want to make a bar chart. I'm going to format the share as a percentage on the axis. And I see that the specialty that has the highest churn among the top 10 specialties is emergency medicine. So 44% of physicians who were either 2020 or 2024 either retired or entered. Okay, so obstetrics is a big churn as well. Interestingly, ophthalmology the least. All right, so this is the exam. I'll stop here.